Today's discussion is about the leading corporations, how they're using dramatically fewer materials, less energy, and safer chemicals when they manufacture products. These innovations impressively improve the climate, they address climate change and the natural resource depletion. The community benefits and professional pride is also a great benefit from being sustainable. Engineers, managers, and interested citizens hear a hopeful future based upon real-world examples of this dynamic presentation. Our keynote presenter is Pamela Gordon, who wrote a book on lean and green for the technology industry and co-developed DfE Online, the world's foremost design for environment training, and formed the executive think tank on supply chain, mapping a successful response future for the technical industry. Since 1987, she's been CEO of Technology Forecasters, a strategic consulting firm helping tech companies thrive through best practice supply chains and profitable sustainability. She was recently named among the top 10 women of sustainability, appointed a judge for Clean Tech Open. Ms. Gordon is a prolific writer with nearly 1,000 articles to date, popular keynote presenter, an instructor at UC Berkeley Extension, and a guest expert on radio and TV. Joining her today is Harvey Stone, PhD, is a writer, speaker, and consultant with nearly 30 years of experience in the corporate world. 17 years he's been a speechwriter for Apple, HP, IBM, and many other corporations. He has also co-founded a consulting firm that has assisted Cray, Bosch, and Lohm, and other companies in complying with global toxicity and e-waste legislation. In the 1990s, Harvey was an instructor for UC Berkeley's MBA program. For 3 years, he's hosted a weekly radio program, which has highlighted positive steps towards a sustainable world. Most recently, he has authored Melting Down, an environmental thriller novel designed to reach a broader audience with climate change, science, and its impacts. And with that, I'll turn our presentation over to Pamela Gordon.
Thank you, Jim. Good evening, everyone. I know you might say, well, Pam, Harvey, welcome to the Golden Bear Center. But actually, I want to welcome you because, as Jim said, in 1987, when I started my firm, Technology Forecasters, we were in this building, actually upstairs, 3rd floor. So welcome to the Golden Bear Center. I'm delighted with my colleague, Harvey, to be giving this talk with you, and we'll go ahead and get started. So Harvey's going to help us with the business landscape. Why are we talking about sustainability now in 2013? And what does that have to do with you, those of you who work for corporations, certainly all of us who purchase things from corporations? And then together, Harvey and I will take turns giving you some of the design for environment practices and successes. It's not rocket science, but it's very strategic. So we really want to help you through a wide variety of DfE principles, design for environment principles. Then we'll take your questions. It'll be a mid-class Q&A opportunity. And after that, we'll come back with a how-to on design for environment, DfE. And then we actually have a challenge for all of you and those of you who are participating remotely. And we'll coach you through it, and then we'll conclude. So ready? Okay. The scope of this lecture is today. It's also this quarter. And those of you who are working for corporations, you know that this quarter there are always a lot of expectations each and every quarter. But the scope of this lecture is also all year. It's for the next 5 years. And frankly, it's for your career, and even more, it's your kids' lives. So this is a very, very broad scope of this class, and I know you'll come along with us step by step and see very readily the implications to all of life and all of society. These are objectives. The first thing is we want to help you drive your strategies for those of you working at corporations and those of you who aspire to work for corporations, those of you who are consumers of corporations, so that's everyone. So the next 10 years, we don't want to just look at tomorrow. As you saw on the previous slide, we want to look way at 10 year and even plus. And we want to guide your long-term decisions for what we call the 4 Ps of product, profit, people, and planet. At the same time, we want to give you some tools and strategies so that you can start tomorrow. Tomorrow's Friday morning, a great time to start something new. So we're going to give you practical techniques and differences that you can start to deploy, and also ways to convince your management of the environmental sustainability and design for environment principles. That is so important. Our main intention for this course is that we don't ever want you to think the same again about how products are designed or what you can do to influence them. We want you to think a new way than you ever did before this lecture. Just a quick story about the starting tomorrow and convincing management. Was it last week already? I was in Israel giving a seminar on design for environment and a think tank on supply chain. And one of the audience members said, you know, I agree with everything you're saying. I think everyone does, that we need to design our products and think about our distribution and everything we do differently. But I have my executive, my CEO, who says he wants the next product done in 3 months. And what you're talking about, these bigger schemes, will probably take 6 months, a year, even 18 months. How can you help me convince my executives that this is strategic for our company? So the first thing I said is do designs in parallel, but also a host of tools of how to convince the executives of lean plus green. What do we mean by that? We mean something that is good for the organization's profit, increasing market share, reducing costs, and green. That's also good for the environment, for people and planet. So that's what we're going to convey to you. And as a hint, this is a little bit about what you're going to have to do in the challenge. Okay, so nothing more about that right now. I'd like to say a few more words about my colleague, and he can feel free to embarrass me after this, as I will him. No, not really. I'm not going to embarrass you. Try not to embarrass you. Now, Harvey and I have known each other many years. We've done design for environment workshops in several continents, Europe, China, Canada, North America, United States, I think Harvey also Australia. And he's the author of Melting Down, which is an amazing thriller, which my husband and I read to each other. I guess he loves thriller novels, and I love sustainability, can you tell? So it's really worth reading. And I really admire that he takes not only what he wrote as great fiction, but that he's dedicating his career to really implementing a fix to the severe, serious problems that he addresses in the novel. His corporate clients are many that you recognize, and he was on the U.S.-Japan Sustainability Task Force, and he hosted a radio show for 3 years on sustainability, and he's been a speaker, he's been an influencer in the European Union regulatory environment. That wasn't too bad, was it?
Wasn't too bad.
And myself, I think Jim really went over this very nicely. Thank you, Jim. You'll hear a little bit more about lean and green when we get to the challenge part of this evening. So there's something in this for you. And Harvey and I and our colleague Graham Adams developed DfE, Design for Environment Online, which is an 8-module course in how to actually implement some of what we'll be talking about in these 2 hours. And I mentioned a little bit about the executive think tank on supply chain. Started TFI, Technology Forecasters, Inc., 25 years ago, as I mentioned, in this building, and some other things. So I live here on the East Bay, so this is my home turf. It's great to be here. All right, so on the left side of the screen, you'll see a tree hugger. Thank you. And on the right side of the screen, you'll see a CEO. Specifically, this is Robert Malone, Chairman and President of BP America, testifying with other oil companies. before the House Judiciary Committee on gasoline prices a couple years back. So when I started writing my book, Lean and Green, Profit for Your Workplace and the Environment, I had a friend named Karen. I won't say her last name because some of you may know her. She lives here in Berkeley. But she said, oh, come on, Pam. You know that any corporation that does something for the environment is only doing it for PR. Okay? So there's that point of view, sort of the left side picture here. Okay? And then there were the other colleagues of mine who said, oh, come on, don't tell me about this frilly, touchy-feely things about the environment. You know, all I can concentrate on is meeting shareholder expectations this quarter. So my aim in writing the book, as is our aim in this course, is to address both points of view. So with that, I'd like to ask three brave souls to just shout out, and I'll repeat it just for the camera to hear. What specifically tonight you'd like to walk away with from this course? Because Harvey and I can certainly emphasize that material from what we've prepared. So the first brave soul. Yes?
Tools to use to incorporate sustainability into a corporate strategic plan.
Tools to use to incorporate sustainability in a corporate plan. Did I get that? Excellent. You will get those tools. Thank you very much. Second brave soul. Did we say something about beers after this class?
We did. Over there.
Yes.
Kim.
How to emphasize sustainability when your product does not necessarily have its roots in green and sustainable.
Great. So how to emphasize sustainability even though the product itself may not have its roots in sustainable thinking. Did I get that? Good. Excellent. Excellent. You mean because the product is inherently not very sustainable?
Yeah, like an oil company.
Like an oil company, for example. Got it. Thank you very much. Yes?
Insight as to how companies are already doing this.
Mm-hmm. Insight as to how companies are already doing this, already having real, not just talked about, but real sustainability strategies. Excellent. Thank you. We will do all of that and more. Okay, these are a few quotes by people you have heard of. Probably haven't met some of these people unless you're really special, have a time machine or something. But these are quotes that I think will provide guidance for this course. And some of you may have some quotes that are like this in addition. But these are ones that have inspired me. So with the last quote, we're not going to necessarily tell you 120% of everything there is to know about sustainability in corporations in these 2 hours. But we're going to start, and that's what our obligation is. Okay. So now it's time to turn it over to Harvey for the business landscape.
Great. Thank you, Pam.
Sure.
And thank you all for coming. I really appreciate your interest in being here. And I wanted to talk some about the business landscape to really set the stage for what's going on today. And you know, business, like everything else, like life itself, evolves and has changed dramatically, and the circumstances in which businesses must operate is constantly changing as well. And so for a company that wants to implement sustainability, it has to be very clear to them what is going on, what are the situations, what are the market situations, what are the regulatory situations, what are the customer demands that they are going to face in order to succeed, in order to survive and to thrive in today's landscape. So we wanted to spend a few minutes in talking about what is that landscape that is unique today that businesses must deal with and truly must understand. And those companies that are succeeding, particularly succeeding by implementing sustainability, and there are lots of them, this is part of what they understand. So first of all, what a difference 300 years make. And I live in New Mexico. Any of you have been to New Mexico? A few of you have been here. So there are areas in New Mexico where I can go hiking or walk out into the mountains or out into some of the desert areas, and it's as if I could be living 300 years ago. Because there's wide open spaces, There is virtually no hint of toxicity. There's very little pollution. You can look as far as you can see, and you won't see any waste other than natural waste from animals or some of the plants that give off certain kind. We all give off some kind of waste. But it's almost like living 300 years ago. And when I do that, it really reminds me of the differences that occurred. In the era that when business started to develop, businesses as we know, the modern business started to develop, around 1700, the Industrial Revolution, it seemed like there were unlimited natural resources. My God, all the iron there is, all the coal, all the fresh water, all the plants, all the zinc, all the silver, all the gold. It seemed like you could not possibly get to a place where you would use it up or get close to using it up. And today, we are in serious shortages in many natural resources, many minerals, many metals, many rare earths, fresh water, clean air. I mean, the numbers of them, there are more that are either dwindling in supply or almost out than there are those that are still abundant, given what's happened in 300 years, the amount that we've used up when they are non-renewable. Right? You can see their forests, fisheries, water supplies, as I'm sure you all know, they're seriously depleted. There was abundant land. I mean, in 1700, as I think the next one says, there were less than 1 billion people on the planet. Today, there are more than 7 billion people on the planet. And if I remember correctly, every day, there is something like 230,000 more mouths to feed on the planet as a whole. That's the equivalent of some medium-sized cities in the United States. The population is just expanding, 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 and it's expected to get to 9 or 10 million before it eventually peaks out. And of course, all those people want the kinds of things that we have. They want food, they want shelter, they want iPods, they want cell phones, all of those things that themselves require natural resources. There were few sources of pollution then. If you lived in London, you lived in Pittsburgh, you probably were subject to pollution from the early coal mines. But generally, compared to what we have today, it was a very clean world. And of course, here we have multiple sources of pollution. We probably couldn't write them all down. And then there were minimal gaseous, liquid, or solid waste, right? Hardly enough to fill up, certainly not any city landfill. And today, we can see air, sea, land, all saturated with waste. There's virtually not a city in the world of any size that has spare landfill space. And the whole recycling business that has evolved, thank goodness, is a way of handling a lot of that waste as well as creating jobs, creating tax bases for local communities, et cetera, et cetera. So this is part of what a business today has to deal with, is all of these. And those are all realities. And there's good news and bad news in it. The good news, of course, is if you were selling a consumer product, you have potentially 7 billion buyers for your product. The bad news is increasingly, because there's so much competition, because there are fewer natural resources, that the competition for those resources becomes greater, and because it's also true that we're running out of them. Right? If I remember correctly, in the last 30 years, something like 700 million new people entered the middle class. Now, I know we talk about in the United States the disappearance of the middle class. But in China, in India, in other Asian countries, middle class is exploding. And so in the last 20, 30 years, 700 million new people entered the middle class. Of course, they want what middle class people want, various possessions, different kinds of food, eating meat, et cetera, et cetera, et cetera. And in the next 30 years, if we were to continue in the same trajectory that we're on, and that's open for debate, I personally don't see it happening, but if we were, it is projected that there would be 3 billion more people entering the middle class, wanting the kinds of things that middle class people want, and therefore straining even more the amount of natural resources, the amount of waste, the amount of pollution that companies it will produce in developing those products, unless they develop a different way of manufacturing. So that's one piece of the business landscape. Another is, this is what I basically was saying a minute ago. Tantalum and zinc, of course, are minerals. They are increasingly in short supply. So if you are in your company, if you are used to using, for instance, either of those minerals in your products, what's going to happen to it? What happens when supplies dwindle? I'm sorry, what?
They get more expensive.
They get more expensive, exactly. So the price goes up, the cost of your product goes up. If your competitor comes out with an innovative metal or mineral that they can use, another way of doing it, they then have a competitive advantage. So companies are constantly having to figure out what's available, what are alternatives, what are the competitors using, in order to be able to keep products low, because we all as consumers want lower products. And also in today's business landscape, I don't know how familiar you are with this, in the last decade, there has truly developed this worldwide web of environmental regulations. The catchphrase that's used for them is product stewardship regulations. And they fall under the precautionary principle. Are you familiar with the precautionary principle? No, maybe a couple of people here. Typically, for the last 290 years, if you wanted to put a product out on the market, you put it out on the market, and it sells, and then maybe about 5 or 10 or 20 years later, you discover that there's a cancer cluster that's somehow related to this product. Or, there's all these people who have used this product are suddenly having endocrine problems. That we find out about the problems after the fact, and then it becomes government's job, whether it's the EPA, whether it's the Center for Disease Control, any of the various agencies in the United States, it becomes government's job to track down and relate that particular product to that cluster of cancer or that series of endocrine disruption illnesses, et cetera, et cetera, et cetera. And it becomes very difficult to do when it's 10 years later. It's very expensive for government to do it, and we're all paying, of course, in our taxes for that. So in Europe, they basically reversed it. They said the precautionary principle, which means better safe than sorry. If I'm a manufacturer and I'm going to put a product on the market, the burden of proof is on me to say that the product is safe rather than on you as the government agency to prove, in quotes, that it isn't safe. And under that umbrella, there are a whole series of regulations, starting in some in the early 90s, but mostly starting after 2000, around batteries, around packaging, ELVs, extended life, end-of-life vehicles. WE is the waste electrical and electronic equipment. It's all the computers, the cell phones, and millions of things, anything that has a battery or a plug. ROS stands for restrictions on hazardous substances. Has to do with 4 heavy metals and 2 polybrominated flame retardants. So it includes lead, cadmium, other nasty things like that, mercury, which is very nasty. EUP is energy-using products, REACH, which is also about toxicity, and on and on and on. That these various directives have developed that companies now have to meet the requirements, and it becomes a big part of any manufacturing company. These are geared towards the electronics industry, electrical and electronic products, that they have to meet them. And it's very expensive to meet them, often very difficult to meet the requirements, and this is all part of the environment today that is driving companies to implement design for environment practices. And of course, the climate is changing. We all know that this is the one, the big one. We don't really know the impacts what it's going to have, but we do know that the floods, the fires, the droughts, the tornadoes are impacting a company's ability to manufacture. If you're a company's ability to ship products, company supply chains, which tend to be global, and if you're having monsoons in certain parts of the world, or you're having dust storms in China, all of those things impact companies, and they have to figure out how to maneuver in this. And it becomes a big piece, and Pam will talk more about this, about what companies are doing these days with their supply chains. Okay. So to briefly just introduce some of the practices and successes, this is the traditional definition of design for environment that comes out of the 1970s, right? And it was a corollary to the Clean Air and Clean Water Acts, to the First Earth Day, a number of environmental pieces of legislation and activities. Interestingly enough, under Republican President Richard Nixon. Okay? And basically it's about minimizing uses of chemicals. You can see that in minimizing the Earth's limited non-renewable sources. These are some specifics. Now this is basically, these are green activities. And I'm curious, just to take a moment, how would you define green? What's a green activity? Something that lessens the impact on the environment? Yes? Yes, sir. Here.
I was going to say it's a stable process that limits the waste that's produced, etc.
Stable process that limits the waste, right? So it's a similar definition, just more specific. Yes, sir.
Simply non-polluting.
Non-polluting, okay. Typically, what green means is less bad. Okay? Less toxicity, less waste, less energy usage, less material usage. So when a product is greener, it means it uses less of something, right? And that's fine. That's a great step. But as a friend of mine describes this, imagine, for instance, that somebody is a thief, right? And they're great at it. And then they decide one day, for whatever reason, that they're going to steal less. Would we give them an award for that? Congratulations, in 2012 or whatever, you win the award for stealing less. We wouldn't do that. Yet we give awards to companies for using less energy, using less pollutants, less toxicity, et cetera, et cetera. Okay. So green was a really, really important step to get us closer to what you were describing, which is the definition that we use, which is really designed for sustainability. And we use design for environment because it's the accepted phrasing in the industry. But today, products, when people talk about design for environment, it's really about how do you take care of the economic issues, meaning how do you make money, how do you reduce your costs, how do you develop incremental revenue, the social impacts, which means how does the product impact human health, how does it impact community water systems, how are workers in the supply chain being treated, all of those factors, as well as the traditional green environmental factors about air pollution and water quality, et cetera, et cetera, et cetera. So that is a definition we're going to be talking about, and that it is done throughout the entire product life cycle. And the middle stage here is a company who understands this will focus on, okay, we're going to do the environmental piece. And then separately, independently, almost as if there's a firewall there, they'll do the social piece. Okay, how are we going to improve the treatment that workers get in our Vietnamese factories, as an example? The really progressive companies are the ones that understand these are all part of the same thing, that they are all interconnected, and you have to deal with them at the same time. Those are the ones that I would consider, and Pam would consider, the most progressive. Okay, so DfE, we would argue, is a methodology whose time has come for all these reasons. It addresses today's global realities. It assumes everything's interconnected. You can see it there. It's a prerequisite in every major market in the world. It's implemented across the entire product life cycle, what you had said. It takes into account design decisions and trade-offs, and it addresses all three spheres. And here's just a few examples that in the last 10, 20 years, 30 years even, DfE, Design for Environment, the base for it, the foundation for it, has been developed in a very piecemeal way, but in very important ways. For instance, the development of green chemistry, if you're familiar with that, it's over 20 years now, 12 principles, excellent work that they do. Here's an eco-patent commons, which is that a number of major companies basically took proprietary patents and turned them into the public so that other companies, they weren't proprietary necessarily core to their products or their business, but they turned them over to the public so that other companies could also use them to reduce, again, collectively environmental damage. Some organizations, this is the Consumer Electronics Association, if you know this group, it is the world's largest association of consumer products manufacturers, has done an incredible job in developing e-waste collection. You can see there, in 2 years, they went from 5,000 to 7,500 collection points. They went in 1 year from 300 million pounds of collected e-waste to 460 million pounds collected e-waste. When companies and associations get it, understand this stuff, and get behind it, they can really do incredibly good things here. And then one more, if you know 3D printing. 3D printing is a whole other new way of print where you print from a digital file rather than having to constantly take new virgin materials or recycled materials, build it, have a lot of waste. So the amount of materials, the amount of energy, the amount of molds, chemicals, the transportation, all of that becomes substantially reduced. So all of these things, we would argue, that have developed in the last 20, 30 years, and many, many, many more of them, really set the stage, set the foundation for what today is a coherent body of knowledge and a coherent body of practitioners of design for environment in many, many companies around the world. And that's what we want to talk about now, which are some of the specific examples of what companies are doing under the DfE umbrella. And Pam?
Okay.
There you go.
Thanks, Harvey. Thank you. Okay, so I know you're all PhD chemists, so... Oh, you're not. Jim, wasn't the prerequisite worked out that these are all PhD? I'm not either. Okay, so we're going to get into a little bit of the chemistry behind design for environment, but you don't have to really be a chemist. This is really about understanding the basics, about how chemistry works together so that we know what to put into our products and our organizations. Okay, so there's main types of emissions to air and water. That's what it comes down to. Okay, soil also, you'd say. But a lot of it is how they interact together. So you can see in this diagram, there might be a benign substance, for example, particulate matter. But as you see in the diagram, combined, it becomes a brown cloud. And we'll see in a few slides from now the lethal result of brown clouds that are typically resulting from what we're doing in our industry, what we're doing to power our organizations, our products, our homes. So it is understanding a little bit about greenhouse gases, acid rain, to see what it is in the combination of the chemicals that we have that we've introduced into our environment, and understanding some of it. There are tremendous impacts on human and environmental health. I think there's probably not a single person in the room or joining us live who don't know someone who's been affected by the environment in terms of health or disease or lifestyle. And the electronics industry, which is one of the industries that Harvey and I are focusing on, is a big culprit. You've heard the expression, oh, the electronics industry, it's a clean industry. Well, no. Absolutely not. So it's not only the chemicals that go into the processes, the products themselves, the output, but it's also the tremendous amount of energy that needs to power the electronics. It's the toxicity from e-waste, electronics waste. So it's a huge culprit. And also, understanding the chemistry helps you make decisions in your organizations and as you as a consumer about what products you're going to buy and how your company can impact the environment in a more positive way. So I promised a couple of examples of this. So this is a photo here of particulate matter, and you can see that it's viewable by satellite. And it's a mixture of extremely small particles and liquid droplets that are carried in the air. And it's known to cause asthma, lung cancer, a whole host of lethal conditions in humans. And it's mainly a result of combustion, of incomplete combustion from the burning of fuels. And you might say, well, I don't live in this particular part of the globe. But I want you to know that on the east coast of the United States, there was evidence of particulate matter that was from the coal-burning plants in China, so that they can actually, like a DNA, they can actually figure out where it's coming from. So it's very much a global issue. I think all of you understand that. So what can product designers do to reduce that? You might say, this is a global issue. How could we possibly have any impact on that? But no, you can. I mean, one of the things for sure is to minimize the use of precious metals. We'll talk in a moment the difference between embedded energy in a product, which is from the energy it takes to produce the materials that are in the product, compared to energy in use, which is what we're all thinking more when we plug in our products into the wall. So precious metals such as gold, silver, platinum, they require huge amounts of energy during extraction. So one example. So now I want to move to one of my favorite topics, which is dematerializing products. And I'm not talking about vaporizing them like sci-fi, but a little bit actually I am. So what do customers want? If you work for a corporation, you have customers. We are all ourselves also customers. What do we really want? Do we want more stuff? And be honest, if there's anyone who really wants more stuff. But I think many of us, it's not that we want more stuff. We don't want to be laden down in our pockets, purses, and briefcases, on our desks in our homes as we travel with stuff. What we really want is a better lifestyle. We want health. We want social interaction. We want education. We want demanding, creative and rewarding careers. We want family. We want adventure. We want friends. This is what we really want. So why is it that our society thinks that the way to win is to produce and buy and store more stuff? So let's debunk that myth and find out how can we have all of our needs met by products without having so much material and extraction. So a key design for environment principle is use less material. Find a way to do it. Focus on the customer benefit. So what about your customer's life, whether it's a consumer customer or a corporate customer, do you want to make better? Start with that basic question. And then if it is a product, a physical product that is, then reduce the mass of the product. Now, if you're buying and assembling and shipping and storing and operating less stuff, you're also saving money, obviously. So don't make bulk one of your aims to increase. So this is how it looks in real life. So we have the raw material. When you extract less, or even if you're using recycled material, if you're converting less stuff into the product that you need, transporting it less, then you've got all the components that go into your product. Remember we talked about embedded energy. It takes energy to produce all of these components. And then the time it takes to assemble the components, in this case on a printed circuit board, if it's an electronic product, to put it in a final case and then to move it to your distributor, to the customer, to the area, and then at the final stage in the bottom right to disassemble and hopefully responsibly convert that stuff into something that can be used again, minimizing toxicity and harm to people and planet. So using less material benefits the entire product's life cycle. We all heard of the 3 R's, and sometimes we add another R for rot, right? Compost. So definitely reduce is the best, because it's got, if you have less mining, less processing, less mass to transport, less to power and to cool, you know how cooling sometimes can demand even more energy than power, less to reclaim and less to recycle, then that is optimal. Yes, we want to reuse when we can, we want to recycle, but it gets worse and worse, although rot's not such a bad thing. But reduce is far better than reuse, and reuse is far better than recycle. So this is why we want to think about our products. So here's an example from home, my home. Okay, so you see 2 DVD players. And the one on the left we just purchased in the past year. It's 45% lighter and 50% smaller. And the one on the right is one we bought about 10 years ago, and it's 4.5 pounds instead of 2.5. Now the one on the left, it does a lot fewer things, it's slower, it's clumsy, right? No, it's the opposite. The one on the left, of course, has many more, about 4 times the features, and is great. So this is an example of how just naturally over time, owing to Moore's law and other economies of scale, that we've been able to shrink our products. So is this enough? Just go along as we are? No, Harvey and I say we can do much, much better than that. So let's talk about how we can do that. This idea came from a colleague of a client of mine, an engineer at HP. There was a contest that was held by Walmart about companies who could reduce the amount of packaging. So there were a lot of great companies who entered the contest. They were able to reduce their packaging by 20%, 30, 35%. But this one engineer at HP said, this is ridiculous. Just design a messenger bag that is the packaging. And through this idea, HP reduced packaging by 97%. You get it, right? It did not by 3%, but by 97%. So this is the kind of out-of-the-box, literally, thinking, sorry, I like puns, that we need to do. And it's smart, it's cool, it's fun. Harvey was talking about how we have finite resources, and we have some materials that are particularly rare. We call these rare earths. And unfortunately, right now, rare earth minerals are a political pawn, especially between China and, can anyone guess? What other country? Japan. Japan, exactly. So China and Japan, some political tension there. China has the lion's share of these particular set of rare earth minerals. Japan needs them. So what's Japan doing? They're doing something called urban mining, where through extremely sophisticated collection and processing equipment, some of the best recycling equipment you've seen in the world, they're reclaiming what's already in our products that we use and no longer need. Fossil fuels, limited, right? There's no disagreement with that. Gold, silver, tantalum, these are all finite materials that's in a lot of the products we use, and we need to do something about it. We talked earlier about how prices go up. There's shortages. It's not unheard of to have wars over, for example, fossil fuels, yes? Some are projecting water will be the next source of war. So shortages can affect your product, obviously. If you can't get raw material in to convert to your product, you can't ship it and bill. It affects your companies, and definitely it affects you. More expensive, less available, supply chain interruptions. So design in fewer rare earth materials. What about plant-based materials? Now, we've talked about the possibility that there are far more materials in our products that are non-renewable than renewable. What about plant-based? Oh, there's advantages and disadvantages. Certainly they're renewable. You grow plants. They tend to be lighter. They tend to have more molding capability. Has anyone seen that computer packaging that Dell is using that's made out of mushrooms? They have a mold in which they grow mushrooms. And funny, the mushrooms grow in exactly the mold they're looking for. It's lightweight. It's exactly the shape they're looking for. It's completely compostable, and it's inexpensive. So it's a good idea. Now, plant-based are independent from shortages of non-renewables, and it can be a competitive differentiator. Why do I know about this Dell packaging? Because they advertised it. Hey, we're cool, we're sustainable, we're doing this mushroom packaging thing. But there are disadvantages too. You just don't want to compete with food supplies. So if you're growing some fuels, biofuels, or something for a product that truly is competing with people's ability to feed themselves, that's not so good. Harvey and I drove over today in my VW Golf, which runs on used soybean oil from a tortilla chip factory. So thanks to Biodiesel Oasis here in Berkeley. So it's not competing with the food supply, it's from waste. So a caveat about plant-based materials, make sure it's a byproduct, it's waste, it's the edges of something that can't be eaten. And why not? So this is a picture in the upper left of the mushroom packaging from Dell. And on the right side is a bicycle made out of, can anyone guess? It was designed in Israel? It's cardboard. Yes. And last week in Israel, I actually talked to some people who've seen it. The keyboard is made of bamboo. Yes, cardboard, bike, bamboo keyboard. And what about this thing? Has anyone heard or seen of this? It looks like an electronic circuit board. Yeah, it is. You see it being dipped in water. Well, there was designed a circuit board that can be totally dissolved in water when the product is no longer used. And you can formulate it such that it can last for a period of days or perhaps 3 years, whatever the useful life cycle is of that product. And so think of e-waste. Now they say, and obviously I haven't tested it, that you can actually drink this water after the circuit board's been dissolved in it. So there is a lot of ideas out there, and why not? Why not? I look forward to hearing some of the ideas that you guys come up with. Okay, I think I'm going to pass the mic back to Harvey.
I wanted to just talk a couple of minutes about designing energy-efficient electronics. And from my perspective, this is really the most important area. It's really important to reduce toxicity, really important to reduce waste. But when it comes to energy, because of what's happening with climate change, with the climate, and the fact that still a huge percentage of energy comes from fossil fuels, that companies, when they design their products to use less energy, use it when we are using in our use phase, meaning we have our computers plugged in or our cell phones plugged in, right? Also in what Pam was saying, in the embedded energy, which is all the energy that goes into extracting the product, extracting the minerals, the metals that go into it, transporting it, making the product, shipping the product to retail stores. All of that is considered embedded energy. Right? So it's critical to reduce both of those. And there are many, many companies that, although it would differ from what you hear politically goes on in our country, there are many companies in the United States and around the world who truly do understand the importance of having to reduce the energy, both embedded and use phase. Right? So just a couple of examples here. Most of you probably have heard of Texas Instruments. They make a number of consumer products, calculators, etc. But they also make chips, semiconductors, that go into a lot of the products that we would use. And while it isn't generally known, the manufacture of semiconductors, they then go into the manufacture of computers and cell phones and many other products themselves, requires an enormous amount of energy and water to do that. And so the Texas Instruments, the Intels, the AMDs, the companies at this level of manufacturer, over the last 10, 20 years, have put a lot of energy, a lot of design time, a lot of money into finding ways to reduce the amount of energy and water they can use. So you can see here for TI, their goal for the next few years, based on baseline of 2010, reduce energy per chip by 45%. You know, I look and say, could I reduce my energy use by 45%? Could you reduce your energy use by 45%? The water required per chip by 45% as well, and they want to reduce their greenhouse gas emissions by 30%. And again, if I were to reduce my greenhouse gases by 30%, it would require a good deal of that. I mean, I'm constantly working at it, but at any given time, 30% is a lot. And so then an example here from Pam's book, Lean and Green, you can see here that as far back as, 14 years ago, they were saving 65 gallons per minute of fresh city water. Again, I live in New Mexico. One of the largest Intel plants in the world is in Albuquerque. Why they built it there, why the state allowed them, the city allowed them to build it there, because of the amount of water that's used. We live in a desert. We're in the middle of a drought. But that's what happened a long time ago. And so it's critical to reduce that water usage. You can see some of the cost savings. And on the energy reduced 45%, you can see there, and then by another 22%. So the point being is that there are a lot of companies who really are putting the time, the effort, the money to make these kinds of reductions and to build greener and more sustainable products around energy. Any of you know Energy Star? Most of you probably know Energy Star. You go into Sears Roebuck and you want to buy a new refrigerator, a new oven. There'll typically be a label on it giving you the Energy Star rating, the amount of energy it uses. Right? Europe has an equivalent. That's one of the earliest ways to help consumers to then help shape the market by buying products that use less energy. And today, because the world is so interconnected, and because there are all these millions, if not billions, of new people entering the middle class and those who would like to enter the middle class, There are enormous business opportunities for companies, for established companies in Europe, in Japan, in the United States, to move into the third world with developing world with new products, right? But the requirement, really, the entry fee here is that the product has to be low enough energy, because often in those areas there's either no electricity or erratic electricity. Okay? The low-income population is high; they can't afford often the product itself, or they can't afford the energy costs of running the product. Okay? So part of the requirements that companies are really looking at is, okay, and they're being driven by the business interests here, and that's fine if they're going to make a profit from it, but it's appropriate to the areas where they're moving into, the markets they're moving into, is it's got to operate on renewable energies, because you can put a solar panel on a house, or you can put a couple of solar panels in the village, right, or wind, or it can be wind up, right? And it has to be a different business model from the one that's generally used in the United States, Europe, Japan, and the more economically developed countries. And you can see a couple examples there of big wind-up products. So as part of the innovation here, and again, companies are motivated now because they know, they see this huge market. If they can figure out how to reduce the energy use, not only will it help the environment by helping to slow down carbon emissions, but it also will help them to sell more product and make more profit, and help the living standards of the people who are in these areas, who can now afford these products and have access to phones, have access to radios, have access to weather reports, and all the things that we take for granted. So here's one example of having of a different kind of solar energy material. Most of us think of solar panels on roofs, all of which is great. Much of that is early generation. There are many new innovations that are coming down the pike. And the advantages of it is it allows the different kinds of business models. So here's one, pay-as-you-go solar. So people will pay, in areas people don't have a lot of money, they can pay for a solar panel, or they can't pay for the solar panel. So this company, 819, what they do is to combine that mobile phone technology, and most people have mobile phones, with solar power, and they can pay for solar as they go. So it's a use basage. Okay? Every time you use it, you pay something. They can buy scratch cards for it, and they can go with called the escalator up there. You can see from the amount of usage that they will use. Okay, another area I want to talk about, it has to do with end of life, valuing products end of life. Right? And this really has to do with waste. And you've all seen the pictures of the amount of electronic waste around the world. I mean, it's rather frightening. We don't have it here very much in this country at all, because most of it we ship overseas. And I don't know if you saw in the papers about a month ago, for the first time that I'm aware of, a recycling company that was exporting waste, a company in Colorado, was actually taken to court and convicted for illegally exporting electronic waste to developing world countries. But the whole area of end of life becomes a huge opportunity for businesses. Not only does it help the environment, it becomes a huge opportunity for businesses, because as so many resources are dwindling, they now have, by recycling, by designing their products for disassembly, meaning when they design the product, they build in ways to make it easier to disassemble the product, to take the product apart, so that it is economically feasible for recyclers to then recycle the product. Okay? And then they will have more access, because on the market there will be more access to recycled materials, recycled parts, recycled subassemblies. So this whole industry, the recycling industry that has developed in the United States and Japan and Europe in particular over the last 20, 30 years, really is reliant on corporations who make products, designing those products so they can be easily disassembled. Because if you are a recycler, what is the most important factor in your ability to make money? Simplicity of recycling. Yes, I'll translate that slightly, but it's the same idea you're talking about. How fast you can recycle a product. how fast you can disassemble the product. So we were talking about the example from a company that Pam and I were involved with a while back, right? In an older version of this product, they had, I don't want to get into it because I don't want to talk about who the company is, but in this particular part, there were 2 screws in the older version of the product. When they redesigned the product, and they weren't thinking design for environment, right? They may have been thinking about some other things, quality, who knows, price, etc. They had 10 screws in the product. Now, if you're a recycler, right, and your business is based on how fast your staff can remove those screws, take the product apart, then go on to recycle it, there's a huge difference between 2 screws and 10 screws. And the odds are that a recycler would then take that product with the 10 screws, mix it up with a whole lot of other things, and just crush it, pulverize it, and then burn it, thereby making all those parts, all those chemicals unavailable to be reused. So this becomes a very big part of what companies are doing, is to design products so they can be easily disassembled. And I mentioned earlier the WEEE regulation, the Waste Electrical and Electronic Equipment Directive. Are any of you familiar with that? No, it's a directive in Europe. Various U.S. states have similar WEEE directives, although nothing nearly as extensive as Europe, or Japan, or Korea, or China. Right? And it basically says that companies are responsible for taking back very large percentages, usually by weight, of the products that they put on the market. So this is part of that product stewardship. And it's part of what is driving companies to implement design for environment, because what happens if they can't meet the requirements of the regulation? They can't what? They pay a fee? Penalized? What differs in those regulations I showed you under the precautionary principle, for most of them, is not that you pay a fee or a fine or a penalty, but that you cannot sell your product in those markets. So if you cannot meet the WEEE requirement, or if you cannot meet the ROS requirement, which is, if you remember, ROHS, restrictions on hazardous substances, if you cannot get the levels of lead and mercury and cadmium and the other chemicals in there down to the levels that the law requires, you are not allowed to sell your product into any of the 27 European Union countries, or into China, which has a similar law, or into Japan, which has a similar law. Right? So you begin to see in the last 10, 20 years, the business landscape has gotten much more stringent for companies. There's much more at stake than simply paying a fee, a fine, which is what usually took place before, say, roughly 2000. Right? It becomes a huge incentive for these companies. So just as a little background here, nature constantly is assembling and disassembling its products, whether those are molecules, whether those are compounds, whether those are plant bodies or human bodies. And nature operates with 5 kingdoms, 5 basic kingdoms here: bacteria, algae, fungi, plants, and animals. And one of nature's operating principles is that the food of one kingdom, the waste of one kingdom, is food of another kingdom. Now that's a whole story in itself. But the key point for this particular piece of talking about design for disassembly is that in nature, there is enormous amounts of waste. There is no creature in nature that does not give off waste. You and I are giving off waste every second or two as we exhale. We're giving off waste carbon dioxide with gases from our own bodies. Right? But in nature, what differs from nature from the human population is that in nature there is no buildup of waste. Because waste gets produced, right? We give off carbon dioxide, trees take it in. That's a simple example. Plants give off oxygen, we breathe in the oxygen. What's happened with human beings is that in the last 300 years or so in particular, we have become brilliant at assembling products, building more and more complex products that can do these incredible things. I mean, it's extraordinary what some of the machines that we've built. The ability to travel to other galaxies, or to really see into the molecular structure of chemicals, of atoms. It's extraordinary. Right? But we have been terrible at disassembling products. And partly we've been terrible at it because there was no reason for it. We had plenty of land to throw things away. Who cared about some pollution? So a little toxicity was given off. Who cared? Because there were so few people, much more land, very few sources of pollution. So this really informs so much of the backdrop, like Pam was talking about with the science behind so much of the chemicals used. This is another piece of understanding nature and companies beginning to really understand nature, how it works, and how we can begin to model a system of manufacturing, a system of retail, a system of consumption, a system of disassembly that mirrors what nature does so well. So just to give you a couple of examples, here's a very simple design shift. This is, you can have a different kind of shaft there. You can build a much more disassembly-friendly one, like the 2 screws versus the 10 screws. That helps the whole recycling business, helps to have more recycled products on the market. This is a much more complicated one from Fuji Xerox, which is a major company. They do a lot of copy machines, a lot of business machines. And this really becomes a sustainability project. It's much more than just green, where virtually every piece and every section of the product life cycle is integrated into a system that absolutely minimizes the negative impact and starts to raise the amount of positive impact that these companies will have in creating local jobs, recycling jobs, community impact, of course, when there is more tax base, when there are more jobs, more businesses. This is an example, byproduct synergy. Any of you familiar with the example, what byproduct synergy is? No. Byproduct synergy is you've got, from your manufacturing process, right? One way to look at manufacturing is that there are only 2 things in manufacturing. There's the product and there is waste, which is the parts of the product that are not used, whether it's energy, whether it's water, whether it's materials. Those are all kinds of waste. Right? So any manufacturing process has some waste. Right? So typically what has happened the last 290 years is a company had some waste. They had some waste energy from combustion. They would throw it in the air and burn it. Or they had some kind of effluent from their manufacturing process, and they would release it into water supplies. Right? Or they had waste materials, right? And they would throw that into a landfill. Right? So part of byproduct synergy is you're manufacturing something. You got your product, you got your waste. Rather than putting it in a landfill, which is going to cost you money, by the way, you're going to have to pay to have it hauled off, and you're going to have to pay a tipping fee to dump it in the landfill. Turns out, I need your waste product. So I'm going to buy that waste product from you, so you now have a new income stream, an incremental revenue stream. I'm likely going to get your waste stream, which is really an input for my manufacturing process. I can buy it more cheaply than I could buy it on the open market. Okay? And then in my manufacturing process, I've got some waste, different kinds of waste. Chances are you need that waste in your manufacturing process. So what happens is, and particularly around industrial parks, and the most famous one you may have heard of is Kalundborg in Denmark. Any of you heard of Kalundborg? Is companies, some of them were manufacturing companies, one was an oil company, there was, I forget what some of the others were, but the whole idea was this happened very organically, they didn't plan it. Companies got together and they started to buy and sell, or sell and buy, each other's waste products. And so that saved them money in buying the materials. Right? It saved them transportation costs because they didn't have to transport very far because they're all in the same industrial park. So this example was very similar. A group of companies based around Kansas City. I wasn't intimately involved with this, but I was involved in 2 workshops with these folks. You can see some of the companies. There are about 30 companies involved. And what they did was develop a byproduct synergy program where they would start to sell their waste streams, make money from their waste streams to companies who saved money because they were now getting those waste streams, which were resources for them, at cheaper prices. And so if you take the whole infrastructure around design for disassembly and recycling, and again, the jobs it creates, the tax base it provides, the opportunities it gives, the more money for schools, for police, for fire departments. This is just from you can see there from Northeast states, right? Some of you looking at it another time, the amount of jobs in the recycling industry, the number, the employment figures, the annual payroll, the receipts that come from those industries, that this infrastructure that is so beneficial to communities begins to develop. And so much of it starts with the corporations designing their products so that they can be easily disassembled. Okay. So we wanted to take a break here. We've given you a lot of information here and examples. And just any questions you have at this point, we've got more to give, but any questions that you have or comments you have about what we've said, Pam and I would love to take a break here and answer them. Yes?
What happens with the quality of the product when you reduce the screws and such?
The question is what happens, was there more? Yeah. Yeah, what happens to the quality of the product if you, for instance, reduce the number of screws by 80%? Yeah. You want to take that?
Yeah, I mean, I remember, it's a great question. I remember well this workshop that we had where this company was like, oh my goodness, we just went in the wrong direction. But they recognized instantly that, the earlier generation product with only 2 screws was fine that way. One of the things we encourage are press fit connections. There's a lot of ways that you can have materials hang together. And so if you minimize the amount of fasteners is the term for the overall collection of choices you have, so that during manufacturing, things go together faster, you save money, the cost of goods sold is less, and during demanufacturing, disassembly, it all happens faster too. So the tension, the stick-to-itness, if you will, of fastener A that's a snap fit may be ever as much reliable, safe, cohesive as a screw that needs to have a tool and a person or a specialized process. So yes, definitely you need to take into account quality, but in many cases these new fasteners that are born of design for environment thinking are even better. Good question. Others, please. Yes.
Can you go a little bit more into details of how Texas Instruments actually reduce their water and energy? Was that on the slide and I missed it? Or?
Oh, I can cover that one. While I'm doing that, though, I also want to invite those who are participating in this class remotely to send in their questions, and those will be offered to us as well. Yes, in Lean and Green, one of the 20 companies profiled was Texas Instruments, and so I learned quite a bit of what they were doing. First of all, the culture of companies can be completely different. So Texas Instruments' culture is less in the loosey-goosey side and more in the engineering side. In fact, it's probably more of an engineering culture than any other company I know of in the world. So what did they do? Those of you who understand semiconductors, there's inputs and outputs, right? So there's so many inputs to the outputs that you have. So they use that same methodology, that same terminology, same culture for reducing energy and water. They said for each chip, each input-output of each chip we produce, can we reduce the water by X and reduce the energy by Y? So what they did is they first identified how much resources they were using per chip. And then they assigned their process engineers, their quality engineers, their environmental engineers to, as quickly as they could, find alternative processes for reducing the amount of water. To borrow an example from LSI, another company, there was a bath solution that they used and throughout. Well, they realized that they could use the same bath 5 times and the quality was fine to use it that many times before throwing it out. So a lot of it is creating quantifiable goals that is aligned with the culture of the company and employing a broad spectrum of people who are close to the process to reduce it. Now, still, Texas Instruments is meeting their goals for they don't just make a goal once and meet it and move on. So they're still doing it. Is it a perfect company? No. I should say, are any of the corporations that Harvey and I are talking about tonight perfect? No. But there's something we can learn from them, and TI is a good example. So I'm wondering if there are any online questions at this point. If not, I see some more live ones. Yeah.
Yeah.
So I know you're focusing on the electronics industry, but the product stewardship regulation and precautionary principles, do those apply? Like, do they cross over to other industries as well? Or,
Just like REACH regulation.
Yeah, there is, some of them do cross over. For instance, I mentioned the REACH regulation that was up there. REACH stands for the Registration, Evaluation, and Authorization of Chemicals. It covers virtually every industry because it is based on the chemical, not on the product. And it's a very strict regulation. And increasingly, there are more and more chemicals that need to be registered, authorized, and many of them will not be allowed. What are called SVCHs, which is substances of very high concern. Yeah. So those really those are very horizontal regulations. There are others that are similar, like ELV, the end-of-life vehicle, has a lot of similarity to the ROS directive that I mentioned, Restriction on Hazardous Substances.
Okay, so let me see if I can condense the question. Thank you. So you're saying that this is more of a philosophical question, and it's about how do you prevent some of this use of, for example, precious metals, aside from, perhaps Moore's Law, which is going there anyway. Did I summarize that fairly enough? Okay. Mm-hmm. Well, maybe I'll start and Harvey can supplement. But what I would say is that it's good to make a list. We had an executive think tank on supply chain in October. Harvey and I and 4 of our other colleagues were there in Silicon Valley. And one of the ideas that the executives came up with is eliminate X, where X is, maybe it's tantalum, or maybe it's even gold, or another substance that's in a lot of products, but we know because of either conflict minerals, which we'll get into shortly, or because of rare earth minerals, or some pollutants, or other reasons we can't really use anymore. So I would say that's an example of being proactive, of not just resting on the rate that technology is naturally evolving anyway, but saying, now here's an example of eliminating X. Some of you probably don't know, but in 1992 there was the Montreal Protocol, which they said, look, we have to get rid of ozone depleting chemicals. It's just, burning a hole in our ozone. So in the electronics industry, to use an example, all of the circuit boards that they just populated with products, with components, and soldering, they washed with these horrible solvents. And the solvents released a lot of ozone-depleting chemicals. So they eliminated it. I mean, it was amazing. I was there, and it was fast. And they moved to aqueous cleaning, which is water cleaning, or even better than that. A company called Celestica up in Toronto, they experimented with no cleaning. So it's not like it's dirty, it's just that it was a process that wasn't needed for some products. So they eliminated it. So that's how I would address your question, is be brave and come up with the substances now that might take you 10 years to eliminate. But you have to get them on the list now. Can I tell one short story about that? Okay, so going back to Texas Instruments, someone else asked about that. So when I was writing my book, the environmental department went to the engineers and said, look, here's a list of the 50 most toxic chemicals in all of our company, not just in our semiconductors, but in our buildings, in the soaps, in the restroom, in cleaning materials, in everything. the 50 most toxic. They said, can you do something about this? So they gave the list to the engineers, and the environmental people thought, well, if we're lucky, maybe several of these can be eliminated by the end of the year. That would be really great in 12 months' time. So 2 months later, the engineers came back, and they said, we're really sorry. So sorry. There are 2 chemicals on this list that we just haven't yet been able to eliminate. We eliminated the 48, but the 2, we probably need another year to do it. And the environmental group was like, what? In 2 months, you eliminated 48 of the most toxic chemicals in our entire organization? How did you do it? So what the engineer said is, we care about the environment too, we just didn't have the list. So my short answer to your question is, make a list, make a roadmap, and get to it.
What I would add briefly is sustainability is a way of looking at the world. It's a perception. And we've had hundreds of years of manufacturing and shipping and retailing and consuming, and a system that has gone global and has become the norm and is very, very, it's got a lot of traction to it after 250, 300 years. Right? And we all participate in it. So shifting perception for a company it's a major shift to begin to look at the business landscape as we've described it and to implement the policies and the practices that we've been talking about here. And from our part, it's important to realize, well, yes, my goodness, companies do lots of bad things. That's, who can deny that? Right? But it's also true that companies are part of a system that everything is interconnected. So as an example, would you rather buy a computer that costs, same computer that costs $400 or the same computer that costs $600? And $400. Anybody want $600? I have one to sell. You'd want a $400, right? Okay. If you are an investor in a computer company, same company, would you like to get 3% annually in your return, or would you like to get 8% annually in your return? You want 8%? Yes. So what happens is companies often get squeezed between customers who want a cheaper product and investors who want a higher return. That is a very tricky balance in a world where resources are dwindling, regulations are sprouting up, competitors show up anywhere very fast. It's all part of a system. So it makes it more difficult for a company to make this perceptual shift, which really is as radical as the world is flat to the world is round. And it takes time. And what we would argue is that we are in the middle of this transition. That hopefully we are the last generation to live through a manufacturing, retailing, distribution, consumption system that has gone on for the last 250 years and produced all it has produced, and that we are the first generation to approach living in a world which is very different. I'll give you a graphic on this in a little while. Very different, that is much more of a sustainable way of manufacturing, retailing, distributing, consuming, et cetera, et cetera. So we're playing at a very high level here. And it takes time, and these companies, some of them don't give a damn. All they want to do is make money, but there are many, and there are more and more, who really do give a damn. And people who work in them working really hard to bring about the kind of changes that we're talking about here. So we should go move on?
Yeah, I think we're going to hold on some questions and move on. So now some how-tos, and very early on in the course when I asked 3 brave souls to come up with what they wanted, one of the questioners said, well, can you give us some tools? And that's about what we're going to do right now. So these are measuring the environmental and monetary return on investment. When I was researching my book, I went to Scotland and interviewed a gentleman named Ian McCowan at Polaroid. And he says that you can't improve what you can't measure. And I think actually that's debatable. But let's go with that for now, because there are a lot of wonderful tools. There's 3 modes of design for environment measurement. There's the company environmental management system. So some of you have heard of ISO 14001. Many of you haven't, but that's an international standard for environmental management systems. There's the product life cycle, so the product-oriented that you can measure, systems boundaries, and there's the company requirements and use of checklists, and you'll hear about that in a moment. And also, if you will, there's 3 phases of product launch at which you can measure design for environment principles. There's the product planning phase, which of course is the most important. You can have by far most impact there. The concept design, and then the detailed design and product launch. So I'd like to walk you through 3 escalating systems of tools for measuring the environmental impact of products. The simple one, first of all, is using a DfE checklist, a design for environment checklist. And at the end of our class, you'll see Harvey's and my email addresses. If you send an email, I will be very happy to send you the latest version of our design for environment checklist. In a moment, I'll tell you what's on it, but it's very easy to use. It's an incremental completion of it. So let's say you have generation A of a product, and on the checklist, only 4% of all of the design for environment attributes you can check off. So yeah, we did that. Oh no, we have 10 screws in it. Oh well, can't check that one off, okay? But then the next generation, B, you've got 18%. In generation C, you skip to 43%. So you can see that it's a way of escalating the environmental attributes, therefore reducing costs, having user value, company competitiveness, etc. The moderate one is the life cycle assessment or life cycle analysis. Very fascinating tool. It used to be so arduous to use. Sometimes it would be a year, take a university a year to do a life cycle analysis on one product. But thankfully today there are a lot of new software products where it's much easier, much faster. And you can measure the CO2 equivalent impact of the product at 5 stages, all the way from, you'd say, womb to tomb or womb to womb, from the extraction of materials from the earth, all the way through assembly, production, transportation, use, and back to raw materials. Now, the most exciting one that we're seeing more and more of, fortunately, is carbon neutrality. And you might have heard that Sony, for example, as you can see, they announced, I think 2 years ago, to achieve 0 carbon by 2050. Now, I'll tell you, when they first came out with this goal, they admitted they didn't know how they were going to get there. But since then, they've started to make some clear interim goals along the way. So it takes a lot of gumption to come up with a goal like this. Tomorrow I'll be at Microsoft talking about design for environment, and you may have heard their carbon neutrality goal. So more and more companies are doing this. And just to maybe bounce off something that Harvey just said, to me, whether a corporate entity cares about the environment or doesn't, ready for this? I don't really care. I don't. I want them to reduce their impact and do what's good to restore a natural environment. And whether they come at that from a profit mode, from a competitive mode, from a fear mode, whatever it is, if it's not we care truly about the environment to the extent that we're going to do this, then as long as they make the goal and it's complete, I'm happy. So I think with a carbon neutral goal, it's a mixture of companies who are doing it for the right reasons and the wrong reasons, but if they're doing it, that's great. I'd say SAP in Germany is one of the examples of a company that's doing it for the right reasons. I can tell you more after the course is over if you'd like. So this is what the DfE checklist is. And you can see in the top part, there's questions for managers. So remember, another questioner said, how can we convince executives of going about the sustainability path? Well, there's some simple questions about business models, about are managers rewarded? Are they compensated based on meeting certain environmental or sustainability goals? Is the CEO really behind it? Or is someone just writing a message for him or her to spout? Are there management by objectives? So it's a simple checklist that lets you know, is your corporation set up for it? Was talking with a client yesterday on the East Coast who is has the Design for Environment online and wants to roll it out to the whole company. He said, you know, Pam, I can buy the corporate version of this product, but if my executives aren't behind it, no one's going to do it. So this is really, really important. Notice it's on top of this slide. Then you've got the questions for designers, supply chain managers, logistics professionals. It's product specific. And this is where, as I said earlier, you have a checklist. You know, how many fasteners have I used? Have I attached plastic to metals? Have I put two substances that are differently recyclable inextricably attached? How fast can the battery come out? And if I minimize the amount of materials, on and on. It's not rocket science. It's really great, and I so look forward to sending it to those of you who request it by email. So I want to talk about 2 case studies. Has anyone here heard of the company Tell Labs? They're based out of Chicago area. Yeah, a couple of people. So the people who founded it came out of Bell Labs years ago, but they're a good company, telecommunications, and their challenge is, as Harvey was saying, they're facing an extreme acceleration of environmental regulations from around the world. You know, Brazil's battery law and South Korea, this, it's just, everywhere. So what they did is they had Design for Environment training for all of their designers. And it was in Asia, specifically in Shanghai, in Europe, in Helsinki, Finland, and all over North America. And now they're all on the same page, and when there is a product that's designed, it has to go through an internal audit to make sure that those DfE checklist items are done. And the result is, with the training, the engineers have been able to generate cost savings because you use fewer materials, easier to assemble, lighter weight, less energy, et cetera, in manufacturing, use and reuse and or recycling stages. And at the bottom is a quote from the gentleman who commissioned this. This is a similar but different case study, much closer to here in Sunnyvale, California, Blue Coat Systems. Anyone heard of Blue Coat Systems? So they make internet security products and accelerators for networks. And they had a problem with, they had to keep increasing the functionality of their systems, but at the same time they had to reduce the environmental impact of them. So what they really needed was objective CO2 data. So they first had us train their engineers in Design for Environment. And then we conducted life cycle assessments of 3 pairs of products. So each pair had an earlier generation and a later generation. So 6 products altogether. We used EcoFly, which was designed by our colleague Graham Adams in the UK. It's a great tool. And we found out as a result that, for example, for one of the product sets, the higher end one, that the latest generation generates only 38% of the CO2 equivalent at the materials phase and only 27% at the use phase over the previous generation. So now customers pay less to operate the systems, marketing has something real and objective to point to, and the engineers feel how? They feel excited and they want to do even more for the next generation and measure that. So these are some of the tools that you can use that are not outside of your reach. Okay, so another area which I'm passionate about even more than dematerialization, and that is supply chain. How many of you are working in jobs or have recently worked in jobs where you're in the supply chain organization of your company? You're purchasing, you're managing, perhaps logistics. Okay, a few of you. Okay, good. So this will ring true. This happens to be a picture of a Bright Manufacturing in Mexico. This is a list of issues that supply chain managers are facing globally. Supply chain managers, VPs of operations who don't care a whit about Design for Environment, or perhaps they haven't been trained in it. This is what they're going through, and it is painful. But when you look at these issues that are ubiquitous around the world, design for environment principles address almost every one. That's a pretty tall claim. So let's talk about it. There's 3 supply chain responsibilities. One is environmental, so conservation and human health. One is social responsibility, protecting the workers and the communities around the workers. And the third is, of course, the fiscal responsibility, reducing the risk of supply chain interruptions. So what's the number one responsibility of any VP of supply chain or operations? Make sure that supply chain or interruption never negatively affects revenue. You can't ship the product, you can't collect revenue for it. So all of this blends together for supply chain responsibility. The fact is, today's consumers, us included, know very little about the products that they use. Who manufactured them? Where? With what materials? What conditions? What kind of living arrangements? There's an attitude of, oh, this was made in China. Oh, well, isn't everything, right? You've seen that. People are conditioned to lower prices equals more stuff. You know, that $400 computer, right? That's the way we've been conditioned by advertising since we were infants. There's a veil of outsourcing. So we look at the brand and we're like, oh, yeah, it's a good brand. Who made the product? I guess they did, right? No? Actually, I have no idea. So the veil of outsourcing, right? Trusted brands with no further visibility. And also, those of us here in the States, in Europe, Canada, we're used to organizations like OSHA, where we have some sense of confidence that the worker conditions are safe. Okay? Not everywhere. So this is the consequence of dispersing the supply chain. Components and materials are sourced abroad. Purchasing is by your suppliers. You don't have visibility to them. What are they buying? From whom? Who is at risk? What are villages like there? How are they being affected? We have no idea. And at the end of life, with Moore's Law, as we've talked about a few times, leading to quick successions of new products, oh, I want that one because it's twice as fast, half the weight. So electronic waste, from storage to toxic dumps, and some of you have seen these conditions, 60 Minutes, or you've read about them. So the globalization of our supply chains is adding to the obscurity of how our products are made and what is in them. I'm sure some of you read about the toothpaste that was tainted with, was it arsenic? About the pet food that was causing deaths? About the Thomas the Train red cars, where there was lead in the paint? So we've heard about these. Now, these all happen to have been from China, where the supply chain, the rigor with which the components that are used, the substances, is much less than in some of the other areas of the world. And that's still the case today, unfortunately. The other thing about supply chain is, you've noticed, the increase of natural disasters, or quote-unquote acts of God, if you will. And whereas global warming can be debated, I think that few people are debating the fact that with the immense increase of population, demand on natural resources, the ozone depleting processes we have, the CO2 emissions into the air, that what humans are doing is exacerbating some of the quote-unquote acts of God. And this affects our supply chains. So what can be done about it? Why are we talking about supply chain in a Design for Environment lecture? Because when we conceive of and design products, we can make some very early decisions. For example, what substances go into the products? Why not choose substances that can be sourced locally, where there's more visibility into the labor conditions, into the toxicity of the output, into the water use, etc.? Why not design products from the start to be manufactured with as high automation as possible. Okay, so we've all heard about the $1 labor rate in China. Well, that's not true anymore. It keeps increasing. But even if that were still true, or find $1 or something else elsewhere in the world, even though the labor rate is lower, it doesn't mean that the cost of the product is. Case in point, again, from last week's workshop in Israel, there was one gentleman who was telling me at lunch, because we were talking about regional manufacturing strategies. He said, you know, we were manufacturing our product with a U.S.-based contract manufacturer, but in their Mexico division. He said it was great. You know, we got product. Mexico's a nice low-cost region. He says, but then we did the math. And he's an engineer, so, people like math. And he said, what we found out, it's actually less expensive to build this product in Israel. And I know what you're thinking. You're saying, how can you compare the labor rate in Mexico with that in Israel? And granted, you're right. It's much lower in Mexico. But the number of workers they had per assembly line was many-fold times higher than what they had in Israel with the more skilled workers. And the number of quality issues that they happened to have in this Mexican facility and the intense amount of soldering manual rework that was done lengthened the product launch cycle, took longer, many more hours, and plus quality wasn't as high. Now, in Israel, they had higher automation. They were able to design the product for the maximum amount of automation. They had maybe 2 or 3 skilled workers per assembly line, far fewer. They had advanced soldering technology, which prevented the defects that then in Mexico cost the time and the rework and the quality issues. So he said it's not an emotional decision. He said the numbers say it all. So I invite all of you, when you think about where your products are being manufactured, either at your companies or products that you buy, don't assume that because they're being manufactured in a low labor rate, far off place, that the cost of the good is lower. So the other thing is risk of supply chain disruption, as we're talking about political and natural disasters, and also the fact that there's some organizations like the EICC, in this case it's the Electronics Industry Citizenship Coalition, where you can really have other companies and support around doing the right thing with your supply chain. So this is a quick example. Many of us here, especially in Berkeley, wear Patagonia clothes, right? That's good stuff. So Patagonia has been a wonderful model for their social responsibility around the world and the footprint of their products, how transparent the products are from the materials and the labor conditions and the wages and how people are living and treated. And customers can actually track online the impacts of the product. And this is something that we see is going to be commonplace in the next few years because this is what we want and this is what we're demanding. So from a design for environment standpoint, consider regional manufacturing strategies, design for higher automation, and make sure that you lift that outsourcing veil and really look at what's happening for your suppliers. And I pass it back to Harvey.
So let's go back to the shift from the world is flat to the world is round. Anybody think the world is not round? Just want to make sure. That must have taken probably a good 50 to 100 years for that to settle in. I mean, most of us were taught, so I certainly was, that we learned the world was round when Columbus in 1492 sailed, heading for the east and landed in North America. But really, the evidence was starting to mount well before Columbus, and probably wouldn't have gone if there hadn't been the evidence. But if you were, let's say you were in the shipbuilding business in 1460, 1470, 1480, and this guy comes to you and says, I got an innovative idea that if we sail, we can reach the east by sailing west. Would you invest in it? Would you send your ships out? Because you've probably spent your entire life being taught in school, in the church, other places, that if you sail out too far, you'll fall off the edge of the earth because the earth is flat. And so there was a whole period there in which there's a conservatism, if you will, a tendency to go with what we've been doing in the past because that's what we know and because the future is risky. Well, in many ways, that's where we are now. And as we've talked about here since we started, our point of view is that initially design for environment, whether it's driven by moral reasons, whether it's driven by political reasons, whether it's driven by profit reasons, whatever it's driven by, has really evolved from a piecemeal, an engineer here doing this, a company over there doing that, to a time when today, in 2013, it is a coherent body of knowledge with a well-developed body of practitioners who know how to do this. And that design for environment is set, the stage has been set, and it is already starting for it to go mainstream for all the reasons we have talked about, whether they're moral reasons, whether they're regulatory reasons, whether they're profit reasons, that it really doesn't matter. As Pam was saying, we don't care why, but that it is happening, that companies are doing it. Okay? And that in the next few years, certainly within the next decade, we expect it will truly explode because those are the companies who will have lower cost, safer products, better PR. They'll have the government off their backs because they will have moved beyond compliance, and that will then begin to set the stage for the entire market. That there is a good chance that that will happen, and of course there's a possibility for all of us to play a part in that by purchasing products that really truly are designed with the environment in mind and designed in the broadest sense of that word, meaning worker treatment and community health and all those areas. So just to give you a couple of examples here of what is happening and may happen, these are just some of the companies that are running 100% of renewable energy. Now, you won't hear very much about it in the media. Anderson Cooper will not talk about this. Why? Because it doesn't sell advertising. It doesn't get eyeballs. It's not as interesting as some toxic release. So the amount of positive stories that are happening that are not reported, not necessarily out of malfeasance, but because they will not draw enough people and therefore sell more advertising. But these are just some of the examples. And more companies are moving to more and more renewable energies. This one is prototype, ecoliners. Right? These are hybrid cars. Right? These are hybrid shipping vehicles, partly gas engines, typical shipping engines, partly you can see the dynamic sails, and the estimates are that this will reduce 50% the carbon emissions that are released by shipping products, big car tankers. Batteries today, what are they made of? Nickel, lithium, all kinds of metals. Right? All kinds of mining involved with it, all kinds of destruction to the environment in mining. Right? All the energy, carbon releases in mining it. They're now developing batteries that can be made with a renewable source energy, and as long as it's from sustainably harvested forests, it then becomes part of the sustainable cycle. This is what I was talking about before, the linear system that developed for 250, 300 years, what's often called the take, make, waste system of manufacturing. Take raw materials, make product, throw the waste away. Everything we suffer from today comes out of that system, or most of what suffer from today. Increasingly, we're seeing development of circular systems. Right, here's one example. This is the making of beer. Traditionally, this is how beer is made. These are the inputs, very simple, hops, malt, yeast, and water. Make the beer, and those are the waste products. Right? Waste water, which is often contaminated, and spent grain. Sometimes the spent grain is sold to farmers who use it for pig feed or animal feed. Right? But what a waste of all of that waste. All the minerals, the materials that are part of it, the compounds that are part of it. There's a whole system that can be developed where everything is used, just as nature uses everything. And there are a number of systems with different kinds of products. The initial work tends to be with agricultural products, coffee, beer, other kinds of crops. But we start to move up the manufacturing chain by developing a roadmap for the next 10, 20 years. okay, of what could happen, what we believe is going to happen. Today, there's probably not one, I couldn't name one of the Fortune 2000 companies that does not have a number of DfE elements in it already. Most of the companies that resist of any kind tend to be smaller companies who can't afford it. Right? But most of the big companies, the brand name companies, are moving in that direction, have to move in that direction. And this is a project I was involved in a few years ago. Basically, we said, what if the electronics industry were to become a cyclical, zero-waste, sustainable industry by 2030, 2040? What would that look like? This is just our little fantasy one day of putting this together. But once we begin to see that this is what is possible, and we get enough companies and enough people within those companies committed to it, we can move there and move there very fast. And the groundwork has been laid. That's the last 30 years, thankfully. We're getting right to the edge there. Okay.
So we'd like to wrap up with the challenge that we've been promising. And if we go to the next slide. So the left hand of the screen is what you can do if you want to take our challenge. Okay? You think of a product that you're using, that you'd like to buy, that you had in the past, or a product that your company manufactures and sells. You think of 3 design for environment improvements based on this class or your other research. Be specific. So reducing screws from 10 to 2, for example. That would be one specific example. Come up with convincing arguments. Because remember at the beginning, one of the 3 brave souls talked about what can we do, especially someone said, what if the product itself is inherently not a sustainable product? So challenge yourself. Come up with first of all, come with really efficient, effective DfE principles and then convincing arguments. And then by 1 week from today, email them to Harvey and me. So that's your commitment. Our commitment is that after January 24th, we have a week to go through your ideas and provide you feedback by email. And if you tell us today, if 7 of you are the first to tell us after we formally close this class that you will do the left side of this screen by the deadline, we will give you, in full trust, like a handshake, a copy of Lean and Green as a gift. Okay? Now, more than 7 of you can do this as well. It's just that we just happen to have 7 copies. So that's the commitment. That's the challenge. And we'd like to see if there's any questions about the challenge and any questions altogether.
We have about 10 minutes.
Oh, yes. Okay. So this is a question from the online audience. Are you familiar with Walmart integrating the sustainability index into their supply chain, and do you think it's effective?
Yes, I am familiar with it. Thank you for the question, wherever you are. And I do think it's effective, because when you take what is often the world's largest company, it varies who's the largest company. Sometimes it's Apple, sometimes it's Walmart, sometimes it's Exxon.
Right.
Yeah, by revenue, whatever the index is, that it certainly is an enormous company. There are millions of suppliers when you take into account the suppliers to the suppliers and the suppliers to the suppliers to the suppliers. And while certainly there are many questions about Walmart practices, it's not to deny that, but the impact that they have in packaging, in transport, in what goes into their products, when you get those giants pushing that down the supply chain, yes, it has a tremendous effect.
Thank you. Other questions from online or in the room?
I think one of the really interesting things that you mentioned, Harvey, was that in your vision, that once this all comes together, there's so many players, everyone's buying in. But especially with the electronics industry, I'm looking at my phone, and I might want a new phone in another 2 years or so. So how does a company, an electronics company in particular, compete with the pace of innovation and the consumers that just want faster, glitzier, but you as the company are like, oh, I want to be more sustainable. I want to make a product that lasts longer. How do you reconcile those needs? It's a very aha moment there.
Thank you. So, just to start out answering the question, one of the DfE principles is modular design. So if you really think several generations ahead, you can think, what is the overall dimension of a product that we're going to use, and we know over the future it's going to get faster, more capability, more bells and whistles. So if you use modular design, you can plug and play what you want to do to increase the functionality of it. And one of the models that's so exciting is the leasing model. I mean, our parents or our grandparents, they didn't own their phones, right? They leased them from Ma Bell. So there's a lot of excitement about going back to the leasing model where these upgrades, the refurbishment can be done generation after generation, and there's more customer loyalty because the company's getting checks every month or ATM transfers, and so it's really a good model all around.
Yeah. And the other piece I would add, which is much more difficult, which is our behavior. To say, I don't need a new cell phone. And it doesn't have to be as glitzy. It doesn't have to have that much more functionality. I've got enough. That may start to happen as we begin to really understand the impact of wanting a new phone every couple of years, of wanting new this, new that, new this, new that. But we're not there yet, of course.
Yes.
That's my question. Just about the human factor in all of this. What do you run into? What have been your greatest challenges and your greatest joys in the work you're doing?
I think for me, the greatest joys for the human factor is seeing engineers light up, once trained in DfE, to see their imaginations take off and see the connection they make, that they personally can make a difference, not only in how sellable and competitive and efficient and cool their product is, but that they can decrease the particulate matter over the Indian Ocean. I think for me, connecting the dots between a little bit of knowledge and some know-how about how to reduce some of the planetary ills is the most rewarding for me.
It's a hard question. Certainly one of the most frustrating is to run into that brick wall of somebody who still thinks, the world is flat and will always be flat. But the fewer and fewer of those people. The best part, I would say, for me, is when somebody gets it. They suddenly make that shift, because it's amazing grace. Before I was blind, now I can see. It's those kind of perceptual shifts that may take decades to happen, but when they happen fast, and all these worlds open up. And people get very creative, and they get very innovative, and they suddenly catch fire by what they can do. And when you have that in an entire company that is committed to it, it's not just one individual here and another individual in that department, but the companies behind it, particularly because the executives and the shareholders and the management get it, that gets very exciting. And we're approaching that on a much more global scale than we ever have before.
Would you please address the DfE attitude about repair and recycling? For instance, you suggested that snap fasteners are an improvement over screws. But for anybody who's ever worked on things put together with snap fasteners, you often find out that things cannot be disassembled for repair. Or when you do, you destroy the snap fastener that was holding the thing together, whereas a screw can be unscrewed and rescrewed.
You raise a good question that some fear that people have expressed about design for disassembly is like, we don't want our customers taking apart our products. What are the liabilities of that? But we've also had some companies say, what? Put a used substance in our product and sell it as new? So very quickly, to all of those concerns, I would say, first of all, you do want to take into consumer safety in mind, of course. But you know that even today, people, if they want to take something apart, they can. And the other thing is, if you've driven a car recently, you might know that a huge amount of the insulation and the car doors and so forth is out of used T-shirts. So we are, in fact, buying new products all the time that, by the virtues of design for environment and Recyculate, other systems have been dismantled safely and become inputs for other products. Thank you. One more question, and then we need to end. on time. Yes.
You said earlier that corporations now are having to deal with expectations from shareholders and consumers. Do you see in the future that leading to corporations going back to privately owned companies, such as what the speculation with Dell and the shortcoming?
The primary reason, by law, most corporations, unless they're one of the new B corporations, benefit corporation, which have in their charter the requirement to consider social and environmental impacts. Right? Most, a vast majority of corporations don't have that. They're about making money. Right? And so what we've witnessed is that companies are seeing that they can make money by reducing material, reducing energy usage, getting better competitive position. So what I believe will happen is that the companies will stay public, most companies, because they can make money doing this. And the companies who, whether they're public or private, who don't adopt DfE principles, don't comply with the worldwide regulations, will struggle and die. Many of them will die, go out of business.
I completely agree with Harvey. And just to give an example of it, one of our clients, Blue Coat Systems, is a company, for example, that I shared a case study with. They've gone private in the past, I think, 18 months from being public. And one of the benefits is that they don't have this 3-month noose hanging over them. And so some of the design for environment improvements they wish to make, which may have a slightly longer lead time or not, will have a better chance of being approved by management. So I think either way, you have a tremendous opportunity from a fiscal, competitiveness, supply chain, market share, and responsibility factor in using DfE. I think that's all the time we have. So Harvey and I would like to thank you so much, those of you in the room and those of you participating online, and best wishes to you.
Thank you.